Alright, so we got the heating element installed in the load controller enclosure last time, and during that video I mentioned something about like maybe some sort of a gear reduction between here, between the valve and the stepper motor, because before I just had it basically in line like that, and it was just a direct drive from the stepper motor into the valve. And what I wanted to do was give it some sort of a gear reduction so that each step in the stepper motor yielded a smaller step in the valve, so that, you know, so that I'd had better control over the position of the valve, so it didn't move in such large increments. The other thing I wanted to say near the beginning of this video was that I know that this type of thing isn't exactly popular on this channel, and most people are probably here because they wanna see engine stuff, but I do have to get through this. I need to get this working better before I do any more kind of dyno testing. So anyway, just bear with me on this. We'll get through it, and probably in the next, maybe if it's not the next video after this one, it'll probably be the video after that, where we'll be back in the garage. Hopefully it'll be a little bit warmer then, and get back to work on the engine itself. I got ideas about that, and you know, so anyway, let's get back to this. And so here's the way I'm gonna go about getting the gear reduction that I want. And I found these gears here, and this is a both of these shafts are 10 millimeters, and then there's that gear there. This gear here is a 34 tooth, and this one is the larger one's a 96. And if you divide those two together, I can't remember exactly what it was, but it was a little less than 3. The gear ratio between them would be about a little less than 3 to 1. So that'll give me almost 3 times the resolution in the valve position than I had before, which I think that ought to be a pretty good improvement. Now, what these gears are made out of is they're steel gears, and I forget, it's kind of like a black oxide finish on there. I can't remember what that's called, but it's a pretty typical. They're not hardened, they're just plain steel gears. I don't know what type of steel it was, but they are steel. So really, in terms of the strength of these gears, they're way stronger than they need to be for this application. But this is what I found. I had more options in this type of material, and in terms of like gear sizes and whatnot, and the shaft size that it needed to fit. So I went with this one, even though it's really stronger than it needs to be. So, but let's have a look what I want to do here. So basically this is gonna go on there like that, and then this gear on here like this, and then they'll kind of go together sort of like that, something like that anyway. I mean, I may end up taking this off and turning it around the other way, and same here, you know, figuring out which way kind of works the best. And then the only problem and then they're not going to be, the shaft heights aren't going to be the same, and the reason for that is if they are the same, these both of these holes get blocked. But if I move it up or down slightly, I can get just one of them blocked. So then I'll have 3 fasteners to hold this to the fixture that I need to make to go here. So that's basically what I'm after. And then for whatever reason, I don't know how the manufacturer intended this gear to be fixed to the shaft, but there aren't any set screws in these. So hopefully this material, like I said, the description of it said that it was not hardened. So hopefully that means I can machine on these without too much difficulty. And then what we'll have to do is go out to the garage, hopefully on a warmer day, and drill and tap the holes for a set screw on here. My first attempt at probably many attempts to try to get the dimensions just right on this mount for the stepper motor mount. Okay, so let me get this over to the printer, and we'll print it out, and we'll see how close we got. Okay, so that finished printing overnight, so let's get that out of there and do some test fitting and see how badly I messed it up. Alright, I guess good news first. is I got these bolt patterns just right so that this piece fastens onto the valve body really nicely, and I got those pockets just right, and all this stuff is pretty good. And I also got the bolt pattern that holds the stepper motor to this piece just right, so they all line up, and the gear fits inside of here. But there's a pretty but when you put this gear in place, a pretty obvious problem turns up, and well, how is this gear gonna mesh onto that gear when all that material's in the way? And the other thing that proves is that I was off by quite a bit in terms of, you know, the distance from here to here. So I'm gonna have to go. What I'm gonna do is I think I'm just gonna take a saw or something and trim that material out of there so that I can see the distance between this gear and this gear, and then we can adjust that distance there, and hopefully be able to tune in to where this needs to be in order for that gear to mesh with this gear nicely. It looks like the gear teeth are just barely touching at the top of the tooth. So roughly, I think what it needs to do is move over about the depth of the tooth. So let me go in and change that, and we'll have to print this for the third time, and hopefully that'll get me pretty darn close. Pretty darn close. So let's do that and try it again. Okay, so this is the third attempt at printing this, and it's really close. I think what I did though is I moved the motor over a little bit too far. It's meshing pretty well, but it's getting kind of pushed together a little bit too much, and there's a little bit of friction between the two gears. So I think what I'm gonna do is just move this gear over away from it a little bit, maybe just 5 thousandths, and I'll bet you that'll be pretty. I think that's going to be pretty good. So let's print this for the 4th time, and then hopefully that gets me across the finish line. Well, it looks like the 4th time was the charm on that. Finally got the gears meshing the way I think they ought to be together there. They're just tight enough together that they don't have any lash, and just a little bit of, it takes just a little bit of effort to turn the gears. So I'm going to run with these dimensions, and so the next thing I'll do is I'm just going to turn up the infill and the perimeters on the part in the slicer and make the final part. Okay, so here's the final print with the infill set at about I think it was 25%, and the perimeters were set at 6. So it looks pretty good. It seems really strong. So at any rate, let me, all I gotta do next is, I want to put some of these brass inserts in here so that the bolts that hold the stepper motor aren't just threading into plastic. They'll be threading into some actual, some brass inserts. Okay, then let me just put that together, and we'll see how it fits. Okay, so it looks like it all turned out pretty good. I like the way that fits on there. The gears mesh pretty good with this final piece. The only problem I kind of ran into was this manifold on here doesn't fit there anymore, but I just need to make a thicker spacer there, and that'll be fine. And maybe I might need some longer bolts to go through it, but well, that's not a big deal. So now, what's left to do is gotta take it all back apart again and get these gears out and get them out into the garage and see about putting those set screws in there. So we'll do that next. Okay, so now I need to put that the hole in here for the set screw that I'm going to use, and I'm going to use a 4mm set screw. So I'm going to find the center of this using this edge finding tool, and then we'll go through and just get started with the center drill, and then we'll finish it off with a the internet said that a 4mm tap uses a 3.3mm drill, and that comes out to about a 0.130 drill size. So let's start doing that and moving along here. So what I did there was I used the edge finding tool to touch off here, zeroed the DRO, moved it over here, and then took that value and divided it by 2 and brought it over till it said 0, and that should be the center of that. Okay, so we got it all back together. I got the set screws installed finally, and I guess we can do a quick demonstration and show you how the valve moves now with the with inputs from the stepper motor, or with inputs from the encoder. And that, I'm pretty happy with the way that turned out. And what I'll show you in a minute is how what the percentage change is per pulse from the encoder, and I got that. That's a little bit better. I got it about to where I wanted it to be. So I think that looks pretty good there. So let me just look at the. So the way the light that I have up here is shining on this, it's making it hard to see the numbers. So I'm just going to turn that off for a second, and we can see how this works. And then the other thing you might notice is that before that would make the valve close and this open it. Well, that's because we put that gear in there, those gears in there, and when you put gears together like that, it makes the shafts turn in the opposite directions. So, but I can fix that in the program. It's just a matter of changing a 0 to a 1 and a 1 to a 0. So I can fix that pretty quickly. So let's close it down. And then there's that temperature thing that we did before. So let's just open it slowly. So before, each pulse was going up about 2%. And this is going up, sometimes it goes 2 pulses for every 1%. Okay, so I like the way that works quite a lot better. So let's move on. Okay, so that's about all I have time for this week. And so to wrap things up, I'm pretty happy with the way this turned out. I think it should help the control of the dyno a little bit, at least a step in the right direction. So there's one last thing I want to do on this that I'm probably not going to have in this video, is that I just want to make a cover for these things here, because water does kind of tend to spray around in the vicinity of the absorber. So I'd like to protect this from those from any kind of water that may leak down onto it. So I'll probably do that, but I think that's I think I'll have to do that later. I think I'm just kind of running out of time to do that in this video, or maybe I will, but we'll see. If I got enough time, I'll do it. And then so I guess that pretty much wraps up what I want to do with this. And then I think next week probably get back out in the garage and actually start working on the engine again. Anyway, I guess that's about all I got for this week. We'll see you next time.